I have started recording. Yeah, it has started. Okay. So if I go back on this question, this was the first question. If I go back on this question and I want you to find the percentage mass of nitrogen, what it will be? Who will tell me what it will be? If I want you to find the percentage mass from this compound, I want you to find percentage mass of nitrogen. How you will do it? Who will give me the answer? How you will do it? What will be the first step? Yes, Ashish. Will you solve it? What will be the first step? Okay, Adifa, yes. Then divided by
basically you'd have to find the molar mass, which would be 14 plus H hydrogen times 4, which is 4, plus chlorine, which is 35.5.
Very good.
To get 53.5. So then you divide 14 by 53.5, which would give you 0.26, and you multiply that by 100 to get 26.1%.
Very good. Good. So this is how you will get the mass of percentage mass of nitrogen. In the same way, you can find the percentage mass of hydrogen and of chlorine also. Okay. Who will Ali? Ali is there. Yes. Ali, can you tell me that how you will find the percentage mass of chlorine if I want? Yes, Ali. Okay, yes, you can tell me like how you will do it. Unmute yourself and you can tell me. Or you can type it on. Okay, yes, chlorine is 35.5. Very good. Then, okay, 53. Yes, Arya, very good. And then, what will be the next step? Times 100. Very good. And you will get, yes. So you will get what? That will be your percentage mass for chlorine. Yes, it will be 66.4%. So that means this is clear. Okay. Okay, Sophia, you are asking from where did 53 came? 53 is like, see, nitrogen, the mass of nitrogen from periodic table. It is 14. Write in your notebook, then you will find like how 53 is coming. The mass from periodic table of nitrogen is 14. Okay. Then the mass of hydrogen from periodic table is 1. What is the subscript given down? It is 4. So what you have to do, 1 multiply by 4. Okay. First nitrogen is 14. 1 multiply by 4. Very good. And then what you will get, chlorine is 35.5. So this is how 53.5 coming. Okay. Yes, it is the molar mass of whole compound. Okay, Sophia, now clear? How did you got? Yes. So how did you got it? From where 53.5 is coming? Oh. Okay, so now, okay, Ali, just pay attention and I will ask you. Is it clear for you now? Okay. So till here, everyone, no confusion. Okay, fine. So no confusion. We can move on to empirical and molecular formula. Okay. Here, you can see two formulas are written. At the bottom, one on with one empirical formula is written, and with the other one molecular formula is written. So how do, like, from this formula, what is your observation? Okay, simplest ratio. What else? And what about molecular formula? What is your observation about molecular formula? What are they? If empirical formula is the simplest ratio, what about molecular formula? What are they? See, yeah, it is the actual ratio. So if C6H12O6 is the actual formula of a compound, when it goes to simplest whole ratio, that will be considered as your empirical formula. Okay, so this is the actual formula of a compound, and this is the simplest ratio of the actual formula given. So this is the main difference between empirical and molecular formula. Now, how to calculate these both? First, we will move on with empirical formula, and then we will go on molecular formula. How to calculate empirical formula? Stepwise we will go on, and then we will calculate molecular formula. Okay, so see, for that, this triangle formula should be in your notebooks. What is that? What is the formula? See over here, mass on the top, mass is written on the top, moles and MR are written at the bottom, and in between there is one sign, that is multiply sign. If you want to find number of moles from this triangle formula, what you will do? See, number of moles, they are written down. So if I want to find number of moles, mass and molecular formula, they are coming in what they are showing you fraction. Yes, they are showing you a division. So what you will do, a line is there. So this line will give you the division, that mass will be written on the top, MR is written at the bottom. So number of moles can be calculated by mass divided by MR. Okay, so number of moles, formula for number of moles will be mass divided by MR, or molar mass or molecular mass. Okay. Now, why I'm showing you this formula first? This I'm showing you because we will use this for empirical formula. To calculate empirical formula, the first step is to find number of moles. So this formula should be there to find number of moles. So number of moles is mass divided by molar mass. Okay, we will move on to the question. See, what is the question? We have a liquid. That liquid has different percentage. In that, carbon is 60%, hydrogen is 13.4%, oxygen is 26.6%. And what you have to find? You have to calculate empirical formula of this substance. So first of all, first step, see, these are given in percent form. Percentages of these elements are given. So see over here. First thing, basically what we do, like, this is to show you that how these percentages are converted into grams. But if you will not do this step, this should be in your mind, that we have assumed that the sample was of 100 grams. Okay, from that 100 grams, we were having 60.0% carbon. So that means from that 100 gram, we have 60 gram of carbon. Okay. Along with that, hydrogen was 13.4. That means from that 100, the mass of hydrogen will be 13.40, 13.4. And from that 100, the mass of oxygen will be 26.6 or 26.60. Okay, this is how you will get the masses, how we have converted percentage into mass, and that masses are of these elements which are present in a sample or in a compound. Now this is the first step. That means you have masses of each element separately with you now. What you will do next? You have to find number of moles. And for that, what you have to do, you have to write mass on the top for each element separately. And down what we will do, we will write atomic mass or relative atomic mass. Or see over here, if you see, I wrote AR and MR. So what we will use in this was a compound given. When if we go back, I will go back. Yeah, over here in this question, was a compound given?
No.
No compound is given. If in this case no compound is given, what you will do, you have to use the atomic masses of the element itself. Okay, you have to use atomic masses of the element itself from periodic table. See the masses of the element from periodic table, and you have to divide with that. Now over here, what we will use? We will use AR or MR. What should we use? What should we write? We should write AR. Very good, Zaria. We will use AR. Very good. Why? Because the mass, we do not have compound, so we will use AR. It will be atomic mass of that element. So the mass of carbon which is given is 60. The mass of carbon, the relative atomic mass of carbon from periodic table is 12. Okay, so it will be 60 divided by 12. Over here, mass which is given of hydrogen, it is 13.4 divided by mass of hydrogen from periodic table, which is 1. Yes. Who is there?
Me, Adifa. Why do we do 12.01?
Yeah, it is when you will see in periodic table, sometimes it is like written 12.01. In some periodic table, it is given 12.01. Okay. So if you will see, for oxygen, the mass of oxygen is 26.6 divided by the mass of oxygen from periodic table, which is 16. Okay. Yes. So now who will calculate? Like what you will do? What will be the mass of carbon? What will be the number of moles for carbon? How many number of moles you got for hydrogen, and what will be the number of moles for oxygen? Find number of moles for each separately. You have to calculate. Just divide them up and give me the answer. What will be the answer? Yes, good, Ali. Very good. 5 ratio 13.3. Very good. And 1.6. Who else? What is your division? What did you got? Who else will calculate? Yes, Bilal. Who has got the calculation? Okay, 5 for carbon. Yes, Bilal, very good. And what did you got for hydrogen? Calculate it and tell me the answer, okay? All of you just calculate and then I will move on to the next. Yes, so see this thing. You got 3.01. Just try the answer, then we will do it. Yeah, 5 for this one, this one, this one. Okay, so this is the, okay. Now, if you see, you have number of moles 5 for carbon, 13.3 for hydrogen, 1.66 for oxygen. Now, next step. This was the step to find number of moles for each element. Moving on to next step. Next step will be that we need mole ratio. How to find out mole ratio? Yes, simplified mole ratio. Very good, Ali. So how to find simplified mole ratio? What you will do, mole ratio, what you will do, see which element from this is having the lowest number of moles. Which one is that? From these three, which one is giving you the lowest number of moles? Oxygen. Very good. So what you will do to find mole ratio, take the lowest one, take and divide number of moles of each compound by that number of moles. Like all of you, you are telling oxygen has lowest number of moles. So what I did in this step, number of moles for carbon divided by the lowest number of moles, that was 1.66. Number of moles which we got for hydrogen divided by lowest number of moles, which was 1.66. Number of moles of oxygen which we calculated divided by lowest number of moles which we got was for oxygen, that is 1.66. So when we calculate it, we will get 3 for carbon, we will get 8 for, yeah, the ratio will be 3:8:1. Okay, you got it. For carbon, we got 3. For hydrogen, we got 8. For oxygen, we got 1. Until here, very good, Ali. So now we can make our own formula. And remember, these numbers should be written down, and this down thing is known as subscript. Okay, these numbers should go down with an atom. Okay, this should be written down, not on this side. It should be written along with the atom for which you have found it. For carbon, we have 3. So that means 3 will go as a subscript for carbon. Okay. For hydrogen, we got 8. So 8 will be written as a subscript for hydrogen. For oxygen, we got 1. So no need to write 1, and oxygen will be written as it is. This is how you will get empirical formula. So what was the first step? First step was, if you have, okay, if you have masses in grams, no need to convert them. But if the masses of elements are given in percentage, they should be written in grams first. This was our first step. Okay. What was the second step? We have to find number of moles for each element separately. And then what was the third step? What we did, we will divide with the smallest number of moles which we feel is, and we will get this, we will get the numbers for each element. And that element number should be written in the subscript to get an empirical formula. Till here, any confusion? Everyone clear with this? Very good, Ali. Reassure it. Yeah, good. Okay. Okay, good. So we will move on to molecular formula now. How to calculate molecular formula. Remember two things. To calculate molecular formula, empirical formula should be with you, and along with that, a mass will be given, the given molar mass. Yes. So empirical formula should be there. Sometime like what happened, empirical formula is given. Sometime what happened, when I will solve the questions with you, you will see in some empirical formula is given. But in some questions, you have to first go through empirical formula, you have to calculate empirical formula, and then you have to calculate molecular formula. So see over here, if we see the question, empirical formula is given, that is P2O5. The mass is also given. Okay, the molar mass is given, that is 284. So now, see, first step. What will be the first step? First step will be that whatever empirical formula we have over here, we were having P2O5. Just find out the mass for this one. Find out the mass for P2O5. Okay, see over here. Who will tell me what is the mass of phosphorus from periodic table? Over here, just collective answer is written, the all together total answer is written. What is the mass of phosphorus from periodic table? Yes, very good. It is 31. Excellent. So what we will do, we have P2. That means 2 times 31. It will give you what? It will give you 61.94 or 61. Okay. What is the mass of oxygen from periodic table? What is the mass? Yeah, 16. And what you have to multiply? You have to multiply it. Yes, you have to multiply it with. Yeah, Bilal, what you will do? Now you have to multiply it with times. Yeah, times 5. Very good. So what you will do? You will multiply phosphorus with 2. Oxygen with 5, you will get 61 for phosphorus, 80 for oxygen. Now add them up and you will get 141.94 or 141 grams per mole. This will be the mass of empirical formula. Okay. So that means now you have mass for empirical formula, that is 141.94. Now, to find second step, what we will do, the molar mass which was given. Yes, Saf, very good. The molar mass which was given, that was 284. Okay, molar mass which was given in the question. See, if you see the question, if I go back, you will see the molar mass which is given. Take that molar mass and the mass of empirical formula which you calculated. Both should be there with you. That's why I calculated empirical formula mass first. The mass which is given and the empirical formula mass which you calculated. What you will do, molar mass on the top, the given molar mass on the top, down empirical formula which you calculated. Divide them up. Okay, by dividing you will get 2. Okay, by dividing both of them you will get 2. Now what we will do with this 2? Okay, fine, we got 2. Now what we will do with this 2? What we will do with this 2, we will take this 2 and we will again multiply this 2 with the subscript number which are already there in empirical formula. So what was your empirical formula? It was P2O5, and with that what you will do, you will multiply 2 which you got by your calculation. So P2O5 times 2. Now your subscript will be 4. How? 2 times 2 is 4 and 2 times 5 is 10. Okay, so this is your molecular formula. Very good, Seth. P4O10. Excellent. So I hope till here no confusion. All of you understood it. So now what we will do, we will move on. Yes, very good, Adifa. So what we will do, we will solve the questions from past papers, how the questions comes and how you have to solve it. I will stop sharing this and I will share my screen with you. So, and we will solve the questions then. Till here, any confusion, if you want to ask me anything, you can ask me. Otherwise, we will move on the questions. Everyone clear with this? Should we move on? Okay, good. So we will move on. I will stop. Yeah, good, Ali. Ali, is it clear for you? Everything is clear now? No confusion, boys. Okay, so I will stop sharing this. Okay, so everyone, can you see now for this one? Like I cannot go back. So if you can see, just unmute yourself and just tell me. Just tell me that, can you see the question?
Yes.
The question is equal to you. Oh, okay, fine. Fine. So we will move on with the first question. Okay. We have titanium ore. In that, the percentage of iron is 36.8%. And 31.6% we have titanium. Now, with this, we have one more element present in a compound, that is oxygen. For iron, the percentage is given. For titanium, the percentage is given. How will you calculate the percentage of oxygen? Who will tell me? How we will calculate it?
Miss, we know that because oxygen is the only other substance besides for iron and titanium, we just have to do 36.8 plus 31.6, and we have to subtract that from 100 to get 31.6%. 31.6% oxygen.
Okay, so if I write this in this way, is it okay?
Yeah,
like
yeah.
If I write 31.6 in this way, so is it okay? 100. The complete sample is from 100, and I wrote 36.8 plus 31.6, and whatever the answer will be, I have to subtract it from 100. So what will be that? That will be the percentage of oxygen. What is the answer?
31.6%.
31.6%. Okay, so you will get 31.6%. Okay, now second step. See one number of moles. What was the second step? We have percentage with us. Now we have to find number of moles for each separately. Now for iron, the number of moles are calculated. Okay, what will be the number of moles for titanium over here? We will calculate. First of all, see what is the mass of titanium from periodic table. What is the mass for it?
$48.
48. Very good. So what will be the first step? What you will do to find number of moles for titanium?
31.6 divided by 48.
Okay, 31.6 divided by 48. What is the answer coming?
0.65.
0.65. Fine. Yes, boys. Who will tell me for this one? Now, what will be the answer over here? Number of moles for oxygen. How we will calculate it?
31.6 divided by 16.
Okay, 31.6 divided by 16. And what did you got?
1.975.
Oh, 1.975. Now, what will be our next step? What we have to do?
We have to divide all of our masses by 0.65.
Why 0.65?
Because it's
Because
the
that is?
smallest number of moles.
Yeah, so mole ratio will be dividing by smallest mole number, or it will be 0.66. Yeah, all of you just calculate and tell me what will be the answer for this, for the first one.
Uh, 1.01.
Okay, very good. For the first one, we got 1.01. What will be the what
One
will
is
be
to
for
1 to 1 to 3.
1?
Oh, I don't have to round it. Okay. 1 to 1 to 3, which is rounded.
It is rounded. Okay.
1
So
1.
who else? It will be like you got what you did. You did 0.65 divided by 0.66. Isn't it? For titanium, how we will do it? What is the number of 0.65 divided by
0.65.
Yeah, see
This
over
is
here.
0.98.
Yeah, it will be 1. It will be 1.
It
Yeah.
will be 1.
One.
Very good. It will be 1. What about this one now?
3.04.
3.04. Very good. Now we got for iron, we got 1.01. For this one, we got 1. And for oxygen, we got 3.04. Now, can we predict our empirical formula? Can we write it?
Yeah, it's gonna be
Yes.
Fe1, FeTiO3.
Fe, okay. Then E, okay, I. And then
O3.
O, P. Okay. This is what you will get. And this will be your formula. Till here, any confusion? Okay. For this question, now I hope that you can find this question by yourself. Can you do it? How you will do it? The same thing. Like see over here, we have hydrocarbon, and in that hydrocarbon, carbon percentage is given to you. That means the rest will be for hydrogen. See what is the percent of hydrogen.
So we just subtract carbon by.
You will
the
subtract
percentage of
it.
carbon by
Okay.
100, and we get
Okay.
14.3.
So that will be 100.
14.3.
14 point.
3%.
3.
Okay, it will be 0.7 and it will be equal to 14.3%. Okay, now what will be our next step? What we will do? We got the mass of hydrogen, we got the mass of carbon, both are there. Now what will be the next step? Same number of moles. You have to find same number of moles, like you will find number of moles for both separately. So how it will be? What it will be? For carbon, how you will calculate it?
12 divided by 39.95.
12. Why 12 divided by? What is the mass of carbon?
It's 85.7 divided by 12.
Very
For
good.
carbon, and then
85.7 divided by 12. Mass of carbon. What is the mass of carbon given in the question? It is 85.7. So what you will do, 85.7, and you will divide it by 12. What will be the answer?
7.14.
Okay. So over here you will get 7.14 or 7.1. Okay. What about this one on this side? What it will be?
For hydrogen, it's 14.3 divided by 1, so it's still 14.3.
Okay, 14.3 divided by 1. What the answer will be now? It will
It's still
be
14.3.
it will be 14.3. Okay. Now what you will do? What will be the next step? This was our first step. See, I wrote over here something. Divide
You
by
have
smallest
to-
number.
You have to divide them both by 7.14.
Very good. The first one we have is 7.14. Down we will divide it again by 7.14. Okay. So what you will get? See, 7.14. Over here, what is the number given? It is
14.3 over 7.14.
14.3.
Very good. And down, what will you divide it with?
7.14.
7.14.
7.14. Okay. So what will be your answer?
2.003 or 2.
Okay, for this one, 2.00. Okay. Over here, you got
Yeah.
2.00. Sorry, 2.00. Okay. And over here, what you will get? It will be
C7H2.
One.
Wait, what?
very good. So it will be what?
C7. C1.
H2.
C1
No, just
H2.
CH2. CH2.
H2. We don't write 1, so it will be
Yeah.
CH2. Very good. So now, till here, clear. Move on to molecular formula. What it will be? We got empirical formula.
You have to multiply the mass given, which I think it was 84.
Okay, you see over here, if you see the mass is given to you, that is what? 84. Okay. So what you will do over here on the top? You will write 84. Okay. What about over here? Like I wrote, see, empirical formula mass.
You combine the masses of carbon and H2.
We
so
will
that's
calculate,
going
see,
to
yes,
be
we will
42.
calculate the mass for this one, and then we can go on. Like, see, carbon is how much?
12.
It is 12.
And then
Plus
hydrogen,
two.
and then there's 2 of
so it's
hydrogen, so
14.
2.
This way, can it be written?
Yeah.
Yeah.
Okay. So now what will be your calculation? What you will get?
84 over
84
14.
divided by 14.
84 divided by 14. Okay. Now what is your answer coming?
6.
6.
6. Okay. So
Yeah.
over here, we got 6. Okay. So
And
now,
then we have to multiply the empirical formula by 6, so you get C6H12.
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 Okay, fine, good. So you will get C6H12 in this way. See, and what we will get? We will get C6H. Clear? Okay.
Yes.
Yes, miss, it's clear.
Okay. There was one more thing. We were doing the questions, and this question, like sometimes the equations are given to you. Just don't go on this. This will be discussed afterward. Sometimes the equations are given to you, and the numbers are missing. Like if you see past papers questions, if you pick some past paper questions like C, X, Y are written number of moles to find the formulas. Along with that, you will get an equation. Okay, by using this equation, you have to predict the formula. Now, how to do this? The first two steps remain same. You have to calculate the number of moles of carbon dioxide. You have to calculate the number of moles of water. Now, same thing, see over here. In the question already they have given you the masses of carbon dioxide and masses of water. So what you will do? You will just simply find number of moles for it. For carbon dioxide, what will be the number of moles? What will be the number of moles for carbon dioxide?
44.
Number of moles. This is the
Oh,
mass
number of
given.
moles.
Yeah, number of moles.
So that's gonna be
It's going to be
44, so it's gonna be 1.
What we will do? The masses are already there.
Divide the mass by
you need
the,
to divide
molar
44 by 0.432. Or wait, sorry,
0.432?
18. For carbon dioxide, 44 divided by 2.112.
Why 2.112?
Because that's the, I think that's the given mass.
No, leave this all. We will just see this afterward. This same thing will come over here. Just find it. Like, give me the answer over here first. I just want the answer from your side. Like, see the masses over here. See this one. The given mass is what? 2.4. Carbon dioxide is what?
2.112.
Okay. And what is the mass for carbon dioxide when you will calculate it?
44 grams.
What? Yeah. So what you will do now?
2.112 divided by
Yes,
4.
2.112 divided by 44. What will be your answer?
0.048.
0.048.
0.048. What about over here? What do we have?
0.432 divided by 18.
Divided by 18. Okay. So what will be our answer over here?
0.024.
Okay. 0.024. We got the answers, yes? So now, what will be our next step? We have to predict empirical formula first. So what will be our next step? What we will do?
Multiply 0.048 by the molar formula by
By the
the
number of moles of
carbon dioxide.
which one is the smallest one? Just tell me which one is the smallest one. Second step.
0.024.
So what we will do? We will divide this by 0.024.
And we get
And
2.
what will be our answer?
2.
What will be the answer?
2.
It will be 2. Very good. Okay. What about over here? Same thing we have to do.
1. 0.0
Divided by.
divided
Yes,
by
yes,
0.
Point
2. It's 1.
024. And what you will get?
1.
1.
Yep.
Okay. So now you got 2 over here. You got 1 over here. Okay. So now come back. We will just pick carbon dioxide, and the second one you will do it by yourself. We will come back to the equation. What is equation written? First, see the first equation. Just leave the second one. You will do that by yourself. What is the first equation written? PbO3, lead carbonate, give you what? Lead oxide and carbon dioxide. So over here, see, I wrote 1 and 1. Was see in the first equation, is any number written over here? Was there any number? Over here, if you see, no number was written.
So
So that means if no number is there, 1 is there for with this. That is the coefficient. Automatically, it is understood that if no number is written, with each of these compound, you will be having 1. That's why I wrote, see, 1 I wrote over here, 1 I wrote over here. Why I did not try 1 with lead oxide? Why? Because they are asking over here, if you see the question. You have to predict the formula for lead carbonate using carbon dioxide. This is C, mole and chemical equation. You have to use moles. Using chemical equation, you will predict what is the amount or what is the concentration used, number of moles used for lead carbonate. So first thing, in this equation, if you see, lead carbonate is 1, carbon dioxide is 1. See, I wrote over here, lead carbonate and carbon dioxide, 1 and 1 for both. Okay. Now, see over here, we need to find the number of moles for lead carbonate now. So what did I did? I just put X over here because we have to find it out. And how many number of moles did you calculate it for carbon dioxide?
2.
In this equation, how many number of moles did you calculate it? 2. So what did I wrote? X to be found for lead carbonate. The number of moles which you calculated was 2 for carbon dioxide.
and because the ratio is 1 to 1, it would be 2 to 2. So X would be 2.
Yes, so X will be 2. Okay, so this can be written in this way also. And if you want to do in that one, the ratio 1 is to 1, so X will be 2 in that way also. Normally the method is this one, that what we do, we write the mole, mole number which is already there, divided by which we have to find it out. And see over here, 1 divided by X I wrote is equal to 1 divided by 2, the number of moles which we got for carbon dioxide. When you calculate, you will get
Miss?
X is equal to 2.
This, we're kind
Yes,
of
yes.
10 minutes above the class.
Yeah. Okay. So this was just the last thing which we have to do. So that means X will be 2. Okay. For this one, for the next one, I will post it on along with this question. You will get more questions to solve and you will do it. Okay. I will stop sharing now.
Okay, Miss.
Okay. So you can leave. Everyone, you are clear with this? Yes. So no confusion, I guess now.
Yeah.
Thank you, miss.
Okay. Welcome.
Thank you, miss.
Welcome.
It was very clear.
Miss,
Stop recording.
post the questions on Edmodo.